Hello, ladies. It's Mr. O'Sullivan. It is Tuesday. This is an Ed puzzle lesson. You are going to be learning about the box method today. The box method is a crucial skill that will never ever go away in your BYW mathematical career. You actually learned about the box method yesterday. It's just a fun way of saying the area model. And we use it to multiply basically polynomial expressions because it's much easier than using distribution and FOIL and all that stuff, because then your work is going to look pretty messy. So today's learning target is I can multiply two binomial expressions by using the box method or the area model. Remember, since it is Tuesday, Miss Townsend and I will be holding a small group session from 1:35 to 2:30. So please attend if you're like, I want to do some extra practice, because we'll be going over some extra practice problems with the box method. That way you can do very well in your Delta Math assignment. So ladies, the box method is simply just a tool that allows us to multiply two polynomial expressions. And the best part about this is it's not one of those math things that only works for a few instances. It works for every single example. So what we're going to be looking at today is we're going to be looking at a few different parts. Part one is simply just setting up the box method. Part two is actually performing it. Part three, we're executing it. And then you're going to do a quick error analysis on Edpuzzle. So part one, setting up the box method. For each of the following, we're going to set up how the box method would look, but we're not going to simplify. We did this yesterday when we did the area model. So please look back at your notes if you're like, I really don't know how to get these numbers in the box. So I'm going to do the first example for us, and then you're basically going to walk me through example number 2. So example number 1, I have x plus 2 times x plus 5. The way the box method works is I simply just put my binomials wherever I want to put them. So I'm going to put my x plus 2 on top. I could put my x plus 2 on the left, but it doesn't matter. And then I'm going to put my x plus 5 on the left. Now that I have my binomials listed, I now need to perform my multiplication. So I'm going to do x times x, which is x squared. I'm now going to do x times 2, which will give me a 2x. And then I'm going to do a 5 times x, which will give me 5x. And then last but not least, I'm going to do 5 times 2, which will give me a 10. We are not going to do anything else right now. We are simply just setting up our box to show you how to use the area model. Now we're going to go on to the next example. So I'm going to ask you, I'm going to do the execution. I'm going to put my x minus 1 on top still. I'm going to put my x plus 4 on the left. If you want, you can color code. Now I have to ask myself, what's x times x? Well, x times x is x squared. What's x times a negative 1? Negative 1x. And one thing I would do is make sure if you are getting a 1x or a negative 1x, actually write down negative 1x or 1x, because one of the things I've noticed over the past few years is that students, when they just write x, they will forget that it's a 1x, and they'll just say 5x plus x is 5x. Now I'm going to do 4 times x, which is 4x. Now I'm going to do 4 times a negative 1, which is negative 4. And again, you just set up the box method. Now you're going to notice these boxes are not drawn in. So the first thing we do is we just draw our box. Pretty good box, if you ask me. Put in enough room for both of our binomials. And now we're going to execute the box method. I typically put my first binomial on top. It doesn't really matter. If you want, let's change it up. Let's put our first binomial on the left. So I'm going to put my 2x plus 4 right here. And notice that I'm writing the sign of the number with it. And I'll do my x minus 3 on top. I'm going to do 2x times x. 2x times x is 2x squared. 2x times negative 3, negative 6x. 4 times x gives me a 4x. 4 times negative 3 gives me a negative 12. I like how this is looking. Our final example, again, we have to draw our box. Pretty good if you ask me. I'm going to make enough room for both of my binomials, and in this case I'm doing 6x plus 2y times 3x minus y. So I'm going to change it up again. I'm going to put my first binomial up top, so I'm going to do 6x plus 2y. Then on the left I'm going to do 3x minus y. Now remember, this is really an x to the first, an x to the first, a y to the first, and a y to the first. 3x times 6x, 12x squared. I mean, sorry, not 12x squared, 18x squared, because 3 times 6 is 18. 3x times 2y, well, you just have to ask yourself, what's 3 times 2? It's a 6. And then I just get xy. Now I have a negative 1 times 6. That's a negative 6. And I just write xy again. And then I do negative 1y times 2y, which will give me negative 1 times 2 is negative 2. And then y times y is y squared. So in this box, I have an 18x squared, a negative 6xy, a 6xy, and a negative 2y squared. So you're probably wondering, okay, now Mr. O'Sullivan, Ms. Townsend, Ms. Jimenez, now that I did all that work, what do I do now? Well, here's what you do. Part 2, now we're actually going to perform the box method. The steps are straightforward. You're going to draw your box with 4 squares, label your rows and your columns, multiply your terms together by multiplying the coefficients, add the variable exponents, and then rewrite and combine like terms. So in this example, I want to multiply the two binomials x plus 2 and x plus 5. So I'm going to draw my box just like the first step said. Draw your box with the appropriate number of rows and columns. So it has 4 squares. I'm going to label my rows and columns. I'm going to put my x plus 2 up top, so x plus 2. And I'm going to put my x plus 5 on the left. Now I'm going to ask myself what x times x is. Well, x times x is x squared. What's x times 2? It's 2x. What's 5 times x? It's 5x. What's 5 times 2? It's 10. So now I have my multiplication done. I have an x squared, a 2x, and a 5x. Now we're going to rewrite everything from that box. So I'm going to have x squared plus 2x plus 5x plus 10. And if you notice, the two terms in the middle are like terms. I'm going to combine them. What's 2 plus 5? 7. So my final answer is x squared plus 7x plus 10. That's your final answer. But the thing is, you actually don't have to rewrite. If you perform the box method correctly, your diagonal will always be like terms. So I could just do it right here, my simplification. I can just do x squared, 2x and 5x is 7x, and then just write my plus 10. You don't need to rewrite all of your terms. You don't have to whatsoever. If you want, you can just do the calculations in your box and then do your combined like terms right there. That's one of the things I prefer about box method. I like it more than what other teachers call FOIL, because you see the like terms in your diagonal. You can just go ahead and combine them. All right. Part 3, we're going to now use the box method to simplify each of the following expressions. So in our first example, we have some nice positive numbers. We only have 1x, a 6 and a 3. So the first thing we do is we draw our box. With 4 squares. And now I'm going to label. I'm going to put my x plus 6 up top. Note, I'm putting my plus with my plus 6. And then I'm going to have my x plus 3. We have to ask ourselves, what's x times x? Well, it's x squared. What's x times 6? 6x. 3 times x? 3x. 3 times 6? 18. Again, you don't need to rewrite. Just look at your diagonal. Those are your like terms. So I have x squared 3x plus 6x is 9x. And then I have plus 18. That's your final answer. You just did the box method. Now we're going to make it a little more challenging by doing 3x minus 4 times x plus 2. But again, if you know your box method rules, you'll be great. We are going to draw our box with 4 squares on the inside. So I have 3x minus 4. Ooh, it's going to be a little tricky because of that minus. Make sure you put that minus with the 4. I'm going to have my x plus 2. Now we're going to multiply. So this is really a 1x. So 1 times 3 is 3. X times x is x squared. 1x times a negative 4 is a negative 4x. 2 times 3x is 6x. And then 2 times a negative 4 is a negative 8. So now, again, I just look at my diagonal. And if you look at your diagonal, I have a 6x minus 4x. So those are my only like terms of my polynomial. So I have 3x squared. 6x minus 4x is a positive 2x. And then I have my minus 8. And that's your final answer. Last but not least, I have 3p minus 3 times p minus 1. So you're not always going to be given x's, but the procedure is the exact same. Draw your box with 4 squares. We draw a box with 4 squares. We put our 3p minus 3 wherever we want. We put our p minus 1 wherever we want. I'm going to change it up now. I'm going to put my 3p minus 3 on the left-hand side. So I have 3p minus 3. And then I have p minus 1 up top. Remember, this is really a 1p. So I ask myself, 3p times 1p? Well, 3 times 1 is 3, and p times p is p squared. 3p times a negative 1? Well, that'll give you a negative 3p. Negative 3 times 1p? That'll give me another negative 3p. And then negative 3 times negative 1 will give me a positive 3 because 2 negatives make a positive. Again, highlight those diagonals. You're going to see your like terms happen right in front of your eyes. And I am left with 3p squared. Here's something I noticed on one of the ed puzzles. One of the questions was, what's negative 3n minus 3n? A lot of you put 0. That is not the case. If I have negative 3 minus 3, that's going to be a negative 6p and then plus 3. That's your final answer. Here's why. If you look at a number line, and I have my negative 3 right here, this is my positive direction. This is my subtraction direction. So if I'm taking away a 3, I'm traveling deeper into the negative numbers. So if I do a minus 3, I'm going to end up at a minus 6. That's why. Now, error analysis. Mr. O'Sullivan and Miss Minaya were working on their math homework together. Sadly, they both had different solutions when they were comparing answers. Determine who answered the question correctly, Mr. O'Sullivan or Miss Minaya. Using complete sentences, explain what the other student had done incorrectly. So if you look, they both had the same problem. They had to multiply x minus 5 times 3x plus 1 and multiply x minus 5 times 3x plus 1. Mr. O is student A, Miss Minaya is student B. So if I look at this, when Mr. O'Sullivan was performing the calculations, he wrote his x and his 5 and his 3x and his 1, just like he should. But there's a difference. If you look right here, Miss Minaya was putting signs on everything. Mr. O'Sullivan wasn't. So, which student answered the question incorrectly? It's pretty straightforward. Mr. O'Sullivan is the one who answered the question incorrectly. Now, using complete sentences, explain what the other student had done incorrectly. So, what Mr. O'Sullivan did was, he did not keep track of his signs. Because if you look, I'm going to make this bigger so you can see it if you're watching it on YouTube. He didn't keep track of his signs. But if you look, he made everything positive. So he was like, you know what, everything's positive. But if you look, this 5 is negative. So he should really have a -5 right here, which changes your answers because -5 times 3x, -15x, -5 times 1, -5, and so forth. So Miss Manaya did the question 100% correct. So you go, Miss Manaya. All right, so that's it for today. Today is Tuesday, so make sure if you have any questions about box method, you stop by the small group session. And as always, if you have any questions, email myself, Miss Townsend, or Miss Jimenez. Have a great day, ladies.